Hello, you absolute legends. My name is Don Kavanaugh, and I want to talk about a little more complicated ligand structure of a transition metal transition metal complex. These square brackets are used in transition metal formulas to show that like all of these things are bound to this metal in the center right here. Now these abbreviations are really indescript, like they're really cryptic. So what I've tried to draw here is the full blown out structure. EN is a really shorthand version for ethylene diamine. Now ethylene diamine has this structure here where the ethyl comes from these two carbons and the di, meaning two amine groups right here, these NH groups right here. Now what's interesting about ethylene diamine is it is a bidentate ligand. Both of these electron pairs can coordinate to the metal and form a really stable 5-membered ring. And it would look something like this, where the N so there are my two carbons, and then the two nitrogens coming from it, and each of those nitrogens have two hydrogens. Okay. So I'm trying to stuff everything in there to account for every electron. These lone pairs are now drawn as a dotted line or as a wedge that's coming out of the board right here. This structure here can be looked as like almost like a flat plate coming in and out of the board right here. We see a 1, 2, 3, 4, 5-membered ring, mucho stable. So ethylene diamine is a bidentate ligand. It bites twice. This is pyridine. Pyridine is what we call a heterocycle. It's called a heterocycle. It's actually a good word, really descriptive. A hetero because it's got two different types of atoms in its ring. It's got carbon and nitrogen making up its ring, and it's a cycle, so it's a heterocycle. The lone pairs are going to donate to the metal center. So looking at the structure here, it's going to be a nitrogen donating to the metal center. I'm going to try to draw that right here. Probably not drawn to scale, but this is me trying to draw the carbons and the hydrogens that are present, and that lone pair is now donated here. Think about how this thing can rotate, and think about how this thing can't rotate because it's bit twice. CN, this final complex right here. Now the lone pair is what is going to be donating to the metal center. Got a good argument for both, and it is an intense topic of spectroscopic study in transition metal chemistry. When you make complexes, which end is biting to the metal center? It can we flip it, can we move it? These are kind of things that inorganic chemists try to look at. So just to kind of get our drawing here completed, let's just pick let's just make the nitrogen biting on this time, like we have for every other one. But that's not necessarily the case. So this is meant to be a coordination number of 4. That's kind of meant to be a menagerie of difficult or unusual ligands that are new to you for the Gen Chem learner. The ethylene diamine being a bidentate ligand, and the pyridine molecule, a heterocycle. I hope this helps. Thank you.